I'll do numbers 2 and 5 in the same video because they both have a similar feel to each other. So number 2, a sample of size n equals 10. Sample size is 10. Is drawn from an approximately normal population. So the population is normally distributed. Perfect. And the standard deviation, the population standard deviation, is 12.5. The sample mean, x bar, is 50.9. And we want a 99% confidence interval for mu, for the population mean. So we want a 99% confidence interval. For number 5, n is 14. The sample mean is 11.9. Whoops, 11.9. And the sample standard deviation, S, is 2.1. And we want a 99% confidence interval as well. Now, the major difference between numbers 2 and 5 is that number 2, we know the population standard deviation. Number 5, we know the sample standard deviation. We do not know the population standard deviation. So these two examples are the two different tests that we'll be using. If we know the population standard deviation, normally distributed population, then this is a z-test interval. A z-confidence interval. Maybe I should say that instead. Oh, let's just call this a z-interval. For number 5, since we do not know the population standard deviation here, this is going to be a t-interval. And both of those formulas are on your formula sheet from Chapter 7. Z-confidence interval for means, here we go. T-confidence interval for means, here we go. The difference is, for the z-confidence interval, we use z alpha over 2 values. And we use the population standard deviation. For the t-confidence interval, we use t alpha over 2 values. And S for our sample standard deviation. Okay, so let's write the formula out here. So we have x bar minus c alpha over 2 times sigma divided by the square root of n, that's the left side, is less than the population mean, which is the population mean is between these two values, x plus z alpha over 2 times sigma divided by the square root of n. So we'll work with this first. If you remember in the last video, I showed how to determine a 99% confidence interval. Do it really quickly again here. Gosh, that's bad. So if I want a 99% confidence interval, I'm saying I want to have 99% of my area here, which means I have 1% in these outer regions, 1% out here. So on the left, that's 0.5%. On the right, that's 0.5%, which is 0.005 if I convert to strict decimal. So we look at our z-score table, because our z-score table gives us the values to the left of our z value, because I want to find my z value, my z alpha over 2 value. I'm looking for 0.005. I'm looking for 5 thousandths. 0.005, 0.005, here we go, 0.0049 rounds up to that. That's a negative 2.58. So this z value here is negative 2.58 on the left, positive 2.58 on the right. So these are our z alpha over 2 values that ensure we have a 99% confidence interval. So I'm just substituting in what I know. X bar is 50.9. Minus my z alpha over 2 is negative minus 2.58 times sigma 12.5 over the square root of 10 is less than my mean, which is also less than 50.9 plus 2.58. It's the margin of error, right? Plus that margin of error times 12.5 divided by the square root of 10. Punch that into my calculator here. So 50.9 minus 2.58 times 12.5 divided by square root of 10. That's the left side, 40.7. And then on the right side, I'm just going to hit second enter to re-enter that, and then just change to plus. So 61 point, let's say 1. Yeah, 61.1. So this means that we're 99% confident that the actual population mean is between 40.7 and 61.1. We're 99% confident that the population mean is between these two values here. I can show you how to do this using the calculator as well. So let's see. So we go to statistics to stat because we're entering statistics. We don't have any tables of values to enter, right? We don't have a data set to enter. So I'm just going to go over to tests because we've already determined that this is a Z interval test. So I'm going to number 7. That's the Z interval test. If I wanted a T interval, I would go to number 8. So 7 is a Z interval test. If I had entered data in that stat edit section, I would enter that, tell the calculator which column I entered the data in, the frequencies, etc. But in this case, I already have the statistics, so I'm going over to stats. Population standard deviation, which we have to know. Let me go over here. Population standard deviation is 12.5. Sample mean is 50.9. N is 10. Confidence level is 0.99. Calculate, and there's my interval. 40.7 on the left, 61.1 on the right. And that's exactly what we had there. So that works. Okay, so if I'm doing number 5, so this is a T interval that we're looking at, right? 99% confidence interval. So we read the table slightly differently here. I'm going to go to the table for the T. Oh, shoot, I didn't even put it here. Give me 2 seconds. Well, it's literally going to seem like 2 seconds for you, but it's going to seem like a little longer for me. Give me a minute. Okay, yes. So we're looking at a T interval here. We want a 99% confidence interval for the population mean for a T interval test. So I go to the T distribution, right? Slightly different than the Z distribution, because right at the top here, I have these confidence intervals. So as long as I know the confidence interval, I don't have to do those calculations. I can just use the confidence interval and go down the column and figure out where I need to be, right? But the one piece of information that I need for the T distribution is called DF, which stands for degrees of freedom. I need to know my degrees of freedom, or what we call D.F. Do you have the formula for that here? No, I don't believe so. So you have to know this. The degrees of freedom is equal to n minus 1. Subtract 1 from your sample size, and you'll have your degrees of freedom. So in this case, 14 minus 1 is 13. Those are your degrees of freedom. That's your degrees of freedom. So 99% confidence interval, 13 degrees of freedom. This is really hard to read. I don't have a ruler here. I believe that's 3.012. 99% confidence interval, 13 degrees of freedom. All right, 3.012 it looks like. So that's my T alpha over 2 value, 3.012. So if I use this T confidence interval for means formula here, right, this is the formula I'm writing out. Let me go back up. So X bar, whoops, what am I doing here? Sorry, I didn't mean to do that. Uh-oh. Okay. X, wait a minute. Am I still on that eraser? I'm not sure what's happening. Hold on. Okay. X bar, sorry about that, minus T alpha over 2 times the sample standard deviation divided by N. So less than my mean, less than X bar plus T alpha over 2 times S over the square root of N. I didn't put the square root here. Square root, sorry. And this is a plus. Doesn't look like it. Don't judge me. All right, so X bar, 11.9 minus, we said T alpha over 2 is 3.012 times the sample standard deviation divided by the square root of N, not N minus 1, right? N is 14. Less than the mean, less than 11, same thing, 11.9 plus 3.012 times 2.1 divided by the square root of 14. Okay. I'm going to put this in my trusty calculator. So 11.9 minus 3.012 times 2.1 divided by square root 14. 10.2 on the left. And I'm going to use the same trick as before. Second, enter, and just change to plus. 13.6 on the right, 13.59, 13.6, whatever you'd like. And I'm 99% confident that the population mean is between these two values here. Now again, you can do this in the calculator, strictly in the calculator. If I go to stat, again, I don't have any data to input, I just have statistics, so I'm going over to tests. T-interval test, we established that already. We're entering statistics, yes. So X bar is 11.9. My sample standard deviation is 2.1. N is 14. And again, we want a 99% confidence level. Calculate takes a little bit longer, requires a little bit more calculating power. 10.2 to 13.6. That's our interval.